Logarithmic functions. This is a brand new function to us, but it's actually closely related to the exponential function. What a logarithm is basically just an exponent written in a different way. Here's what we mean by that. The function that we're working with is called the log. It's going to look something like this guy. Log base b of a equals x. After the equal sign, that part after the equal sign is actually the exponent of the problem. And the base down here written as a small subscript is actually the base of the exponential function. So really this just rewrites the exponential function where the exponent is equal to stuff instead of the exponent being locked into the exponent. We can change back and forth between these two formats, between exponential and logarithmic format, as you start to see that logarithms are really everywhere. So for example, if I've got the exponential function 5 to the third power equals 125, I could rewrite this as a log where the base, or the subscript, is the same base as the exponential problem. Log base 5 of the answer 125 is going to equal the exponent, because a logarithm is an exponent. The logarithm always equals the exponent. So log base 5 of 125 equals 3. 5 to the third equals 125. They're really the same exact expression, just written in two different formats. We can go the other way too. How about this one? Log base b of 3x equals 7. If we were to write this as an exponent, the base of the log is the base of the problem. The logarithm is the exponent. It equals the exponent, so 7 is our exponent, and 3x must be the answer. So b to the 7th equals 3x is exactly the same as log base b of 3x. Now there's one special common log that we work with all the time, and it's the log base 10. We call it the common log because we commonly count in base 10. We have 10 different numbers, 0 through 9. So to shorthand this, you'll often see it written as log x, or log of some number with no subscript, no base written. If there's no base written, we'll just know and assume it's the common log with base 10. And if you look at your scientific calculator, you'll notice one of the buttons says log, or log x. We can use that button to calculate these common logs in base 10. So for example, if we see log of 100 here, and I type in my calculator log 100, by the way, depending on the calculator you have, some calculators require you to type the 100 first and then hit the log button. Others have you hit log and then the 100. Make sure you know how your calculator works. But log 100, it says, equals 2. Which makes perfect sense, because if I were to change this to an exponent problem, remember the base unwritten is 10. The answer is the exponent, and 10 squared equals 100, like we would expect. Now this one was a bit easier because we kind of know that 10 squared is 100, but we can use our calculator to find logs of other things that we don't know as intuitively. Log of 52, for example. I just type in log 52 in my calculator, and it tells me the answer is 1.716, approximately. We had to round it. And what this really means is if I change this to an exponent problem with a base of 10, 10 to the 1.716 should equal approximately 52. And I say approximately because we did round to get that 1.716. So what you'll see when you type in your calculator 10 to the 1.716 power, it comes out to be 51.999, basically 52. So we know our answer is correct. So it's really easy to do a log on the calculator if the log is base 10. However, if the log is not base 10, we need to do some tweaking with it in order to use our calculator. That tweaking is what's called the change of base formula. We can convert any log of any base to any other base with a simple formula. So let's say we have a log base a, which we don't want, of b. We can change it to any other log in a division problem by first taking the log of the inside stuff, the log of the b, and then dividing by the log of the base. I should probably change colors there. the log of the base goes in the denominator. Notice what's inside the log is taller. That taller thing goes on top of the fraction. As we divide, the order does matter. And that kind of helps me remember the taller one is on top because taller people tend to be above the shorter people. However, you can remember this change of base is going to be really nice because we can do base 10 on our calculator. So what we'll do is we will take the log of the b divided by the log of the a. And remember, if it's not written, it means it's a base 10. So for example, if I want to find log base 3 of 81, we can't do that on our calculator, but we can take the log of the tall part, 81, and divide by the log of the bottom part, 3. Now remember, nothing written means this is base 10. So this is actually log base 10 of 81 divided by log base 10 of 3. Be careful that you know how your calculator works. Some calculators open parentheses when you hit the log button, so you need to close the parentheses before you divide. Other calculators require you to type 81 log divided by 3 log. So make sure you know how your calculator works. Try it out and see if you get the same answer as me. When I type in my calculator log of 81 divided by the log of 3, and we get this nice, neat 4. And that makes sense when we think about it, because remember, the base of 3 is to the exponent, which is the answer 4, and 3 to the 4th power is 81. So our calculator was correct in giving us that value. This one we might have been able to figure out without our calculator, but sometimes we can't. Sometimes we have log base 7 of 23, and we don't know 7 to what power is 23. It's between 1 and 2, but we don't know where between 1 and 2. So we'll use our change of base formula, taking the log of the 23, and divide by the log of the base. Remember, with nothing written, that means it's a base 10. So I just have to go to my calculator here, and I type in log of 23 divided by the log of 7. And when I do, I get 1.611. I could check that by saying that really means that the base of 7 raised to the 1.611 power should be approximately 23. And again, I say approximately because I had to round. But if I type in 7 to the 1.611 power, I get 29.99. Base 22.99, basically 23, only off by that rounding error. So that's how we can calculate logs on our calculator. There is one important property of logs that we're going to talk about in this course. When you take pre-calculus at the college level, you'll talk about a whole bunch more properties of logs. But there's one property of logs that we are going to use, and that is if there is an exponent inside the log, it can be moved out in front of the log as a factor. Log base a of b to the x. Let me change colors here. Notice this exponent is inside the log base a. Anytime we see a log with an exponent inside, we can move that exponent out front, so it's x times the log base a of b. That's a very important property for us is when we get to solving with logarithms. That's going to be the key that makes it all possible. But for now, we just need to know how to actually use this property. So if I have log base 4 of 38 to the 2x, we see this 2x in the exponent. We can move it out front. So we have 2x times log base 4 of 38. And we can actually simplify this a little bit better because we can figure out what log base 4 of 38 is using the change of base formula. So we have 2x times the log base 10 of 38 divided by the log base 10 of 4. Well, when I pull out my calculator and type in log of 38 divided by the log of 4. That's 2.62. So we have 2x times 2.62. Well, we're going to go ahead. We've got a 2 here that can be multiplied. Let's multiply the 2 times the 2.62 because it's all multiplied together. And we know that the commutative property of multiplication says that we can multiply in any order. So really that's going to be 5.24x as a simplified form. So anytime there's an exponent inside a logarithm, we can just grab that exponent and move it out front to help us simplify. So that's kind of your brief introduction to logarithmic functions. Really remember, a log is an exponent. You can convert a log to an exponent and convert an exponent to a log. We've got the base 10 button on our calculator to help us calculate logs, and we can change any log to a base 10 log to be done on the calculator. We also covered that one formula at the end that says if there's an exponent inside a log, we can move it out front as a factor. Lots of little details, but none of them really complicated or complex. So take a look at the homework assignment to practice these and really make these concepts concrete so you're ready to go for the next lesson. Have a great day and good luck.